So we are in the module 2 of the chapter 3 of probability and statistics book, and we are trying to solve some of the numericals. Already these are there in the normal class videos, but still, okay, we will try to clarify if there are doubts. So the third problem here is the joint PDF f of x y x comma y is equal to c. It's a constant value. This is the joint PDF when that is in the range of x between 0 to 3 and in the range of y between 0 to 4, and it is 0 otherwise. In the other places it is 0. So what is the value of the constant c is the first part, right? What is the value of the constant c? We need to find the c. So the total area under the curve, because it's a joint probability, so it will be a double integral. Total area under the curve corresponding to this will be double integral 0 to 3 for x and 0 to 4 for y, 0 to 3 for x and 0 to 4 for y. So you can as well, sometimes people will write 0 to x equal to 3. Or sometimes people will write x equal to 0 to x equal to 3, y equal to 0 to y equal to 4, so that it will be clear which integral corresponds to which variable. So x equal to 0 to x equal to 3, x equal to 0 to x equal to y equal to 0 to y equal to 4, okay, because that is the range of values. And the value of f of x, y, f of x, y, x comma y, dx dy, that will be equal to 1. Okay, integral of this term dx dy will be equal to 1, and that is what we have written here. Integral of that, in place of this we have written c, so we need to integrate this. So integrating this just means, okay, integrating with respect to x dx, c dx will give you cx. If you substitute the limits 0 and 3, then you will get 3x. Then integral of 3x, integral 0 to 4 of 3x dy will give us 3c into y, limits 0 to 4, that will give us 12c, and that will be equal to 1. Therefore c is equal to 1 by 12. Therefore c is equal to 1 by 12. Okay, then we have here what are the PDFs for x and y. So PDF for x and y is fxx is equal to integral of same quantity here, only single integral now, same quantity here, dy, because here we want for only x variable, which this should be integrated with respect to dy, and because we are integrating with respect to dy, the limits in the integral will be 0 to 4. So that's why it is 0 to 4 f of x y x comma y dy, and f of x y x comma y will be equal to c, and that c we have found it as 1 by 12. So therefore it will be integral 0 to 4 1 by 12 dy. And now again, if you integrate this, integral 0 to 4 dy, you'll get y with limits 0 to 4, and that will turn out to be 4, and that will be 1 by 12 into 4 will be 1 by 3. Okay, between the limits again, this is, because it is fxx, it should be present between 0 and 3. Similarly, fyy is, integral 0 to 3 fxy x comma y dx. Earlier we had dy, now it is dx. So now if you integrate this, then it will become 1 by 12 into x, limits 0 to 3, that is 1 by 12 into 3, that will give 1 by 4. And because it is fyy is within the range 0 to 4, therefore we should write here 0 to 4. Then the third one is what is f of x, y, x comma y when 0 less than x less than 3 and 0 less than y less than 4. So this is the cumulative distribution function. Okay, cumulative distribution function for this. So for that, again, we should integrate this with a double integral, only that now the upper limit is only x and y. Upper limit is x and y. Okay, the upper limit is here x and y. So here is written du dy. You can write du dy or you can write dx dy, does not matter, right? Limits are here 0 to x and 0 to y. 0 to x and 0 to y. Here it is 0 to 4 and 0 to 3, but here it is 0 to x and 0 to y. When we write the upper limit as 4 and 3, then this becomes 1. Otherwise, this, if it is 0 to what you call y, and this is 0 to x, 0 to x and 0 to y, then this quantity will become f of x comma y, x, y, that is the cumulative distribution function. Again, in the range of 0 less than x less than 3 and in the range of y being between 0 and 4. Then the fourth one is what are the f of x, y, x comma infinity and f of x, y, infinity comma y. So this is cumulative distribution function with the y variable turning out to be infinity here. This is the cumulative distribution function, joint cumulative distribution function with x being infinity. So corresponding to this here, this is nothing but f of xx. When we make the limit of y equal to infinity, then it will become fxx, that is cumulative distribution function of the single variable x, because y is turning out to be infinity. So this and this are same, and that is equal to, there's no point in writing infinity because it exists, the value of y exists only from 0 to 4. Therefore, we are replacing this infinity by 4. So once we replace this by 4, then we have here xy by 12, and the value of y turns out to be 4. So x into 4 by 12 will give us x by 3. You can't substitute infinity here. Please remember that we can't substitute infinity here because the what you call cumulative distribution function here exists only for values of x between 0 to 3 and values of y between 0 to 4. So infinity just can be replaced by the maximum limit 4 over here. Similarly, this infinity can be replaced by the maximum value for x, which is 3 here from the numerical given over here. And now, because it is fyy, y is within the limit 0 to 4, therefore this will be 0 to 4. So in this case, if you substitute here x equal to 3, then you will get y by 4, and that's why this is y by 4. The next question is, are x and y independent? Now, if you try to see here, the equation for independence is this. The joint probability density function is equal to the product of the individual probability density function. Okay, so if this is true, this value is 1 by 12. This value and this value we have just found out here, 1 by 3 and 1 by 4. So 1 by 3 into 1 by 4 is equal to 1 by 12. Therefore, x and y are independent. Okay, that's why x, y, and y are independent. You can as well do it for the CDFs also in place of the PDF. So that means this multiplied by this will be equal to this. This multiplied by this is equal to this. Okay. Let us take the next problem. A bivariate PDF for the discrete random variable x and y is 2.2 del x del y. Now, till now, what we took in the third problem was the continuous random variable. Now, what we have taken is the discrete random variable. So here it is 0.2 del x del y, 0.3 del x minus 1 del y plus 0.3 del x del y minus 1 plus c del x minus 1 del y minus 1. What is the value of the constant c? What is the value of the constant C. So we need to find this. So again, the total, probability value will be equal to 1. That is 0.2 plus 0.3 plus 0.3 plus C is equal to 1. In this case, if you take the double integral of each one of this, or this sum of this, double integral of sum of this, we are going to get the double integral of del x del y will be equal to 1, and double integral of this is also equal to 1. The double integral of this also is equal to 1. The double integral of this also is equal to 1. Okay, so therefore 0.2 plus 0.3 plus 0.3 plus C is equal to 1, and 0.3 plus 0.2 plus 0.3 is equal to 0.8. So C is equal to 1 minus 0.8, and that will give us the value of C equal to 0.2. Okay, that value will give us the value equal to 0.2. So you need to write all that steps. Okay, 0.2 plus 0.3 plus 0.3 plus C is equal to 1, and therefore 0.8 plus C is equal to 1. That is C is equal to 1 minus 0.8. That is equal to 0.2. Okay, that will be the solution. In the same way, the other numerical also, which might be there after this. Okay, values can change. Please remember that. Okay, so then what are the PDFs for X and Y? So PDF for X and Y is fxx is equal to minus infinity to infinity fxy x comma y dy. Okay, so now if you try to substitute for this the value f of xy dy, this quantity, if you substitute, then you will get the integral corresponding to this value will turn out to be 1. Okay, the integral for this will also turn out to be 1. The integral for this also will turn, this will remain as it is, right? This will also turn out to be 1. So we are left with 0.2 del x plus 0.3 del x minus 1 plus 0.3 del x plus C, that is 0.2 del x minus 1. So 2 del x minus 1, this and this. 2 del x, this and this. So 0.2 plus 0.3 will be 0.5 del x. 0.3 plus 0.2 will be again 0.5 del x. So 0.5 del x plus 0.5 del x minus 1. Okay. Similarly, the value of fyy will be minus infinity to infinity fxy xy dx. So we are integrating here with respect to dx. If you integrate it with respect to dx, integral of dx will turn out to be 1. Integral of dx minus 1 will turn out to be 1. This again, integral of dx will turn out to be 1. Integral of dx minus 1 will turn out to be 1. So we are left with 0.2 del y plus 0.3 del y. So 0.2 del y and 0.3 del y will be 0.5 del y. Then 0.3 del y minus 1 and 0.2 del y minus 1. Again 0.5 del y minus 1. So that's why we are getting this equation. Then the third one, that is C. Okay, C is what is f of xy x comma y when 0 less than x less than 1 and 0 less than y less than 1. So this is the cumulative distribution function we need to find. This is the probability density function. Okay, so this quantity f of xy, f of xy x comma y will be equal to 0.2 between 0 to 1 and 0 to 1. So if you try to write it, it is the area within the region 0 to 1 and 0 to 1. So that will be only here we'll get this. Only in this we'll get. Because when this is less than is there, equal to is not there. Please see here, there is no equal to here, right? It is only less than. Okay. So when we say it is only less than, okay, correspondingly, then this quantity will become 0. This quantity will become 0. This quantity will become 0. So all these three terms will be 0. Only this is left. This and this quantity will be equal to 1. So therefore, this will be 0.2. Okay, this will be 0.2. So for 0 less than x less than 1. If it is given equal to at both the places, then that quantity will become totally 1. But because equal to is not there here, okay, so you can't consider this x minus 1 and y minus 1 and x minus 1 and y minus 1, right? So therefore we will be considering only corresponding to this, and therefore that will be 0.2. Similarly, the f of x y, okay, similarly the d part is f of x y x comma y, that is nothing but fxx, and this is fxy infinity comma y, that is nothing but fyy. So those two quantities we need to find. So again, he has written it directly. Fxx is equal to integral of the quantity which is written over here, and integrate it only with respect to y. So if you again integrate it with respect to y, okay, then you are going to get the corresponding again the values over here, 0.5 ux plus 0.5 ux minus 1. Okay, 0.5 ux minus 1. Remember that when we try to get the just fxy x comma y within the whole of the interval, then this will be del x del y. All this will turn out to be u, because it is integral of that. Okay, then corresponding to y, when it goes off, then what remains is with respect to x, and therefore that will turn out to be the same. That is another way of finding it. Okay, this is nothing but the what you call so to say, you can see that this and this have a relation. Okay, fxx and fxx, these two have a relation. This is the PDF and this is the CDF, and therefore if you integrate this over here, integral of del x within the limits 0 to x, okay, this is integral of this with respect to 0 to x. So within the limit 0 to x, if you want, then that turns out to be equal to ux, and again this turns out to be ux minus 1. Similarly here, in place of del y and del y minus 1, you'll get uy and uy minus 1. Okay, then are they independent at all? Okay, so if you take these two and multiply, if you take these two and multiply them, will you get this? Okay, so you will not get that. If you multiply these two, you will not get this. If you multiply these two, you are again not, you will not get the value corresponding to f of x comma y, the PDF value will not get, right? So therefore, we will have, they are not independent. Okay, they are not independent. Okay. So if you multiply this and this, you are not going to get this. They are totally different, right? So that's why it is not independent. So again, okay, so next problem is fx y x comma y is equal to 1 by 1.9079 pi exponential. Now this is an exponential distribution. Earlier we had a uniform distribution between minus infinity to infinity for the values of x and y. What are the PDFs for x and y? Is 3.12 satisfied, and are x and y independent? Okay, so now what is 3.12? We can just see there. Okay, so now we need to, this is this quantity which is there over here is x square minus 0.6 xy plus y square can be expanded and written like this: x minus 0.3 y whole square plus 0.91 y square. Okay, so the fyy will be integral of the f of xy x comma y dx, because we are written y. Similarly, fxx will be integral f of xy x comma y dy. Okay, so we need to integrate this expression over here. For that integration, this e to the power of this quantity, you can separate it out, e to the power of this and e to the power of this, and you can try to integrate, right? So if you try to integrate that, there is only y variable here and there's only y variable here, and correspondingly, we will get the values which are something like this. Okay, 1 by 9079 e to the power of, now corresponding to this value, e to the power of minus 91y square by 1.82. Okay, this is 1.82 as it is, and integral of, so when I try to integrate with respect to x, then the quantity of y can be taken out and only x will remain, and you need to integrate this, and that turns out to be, the integral of this turns out to be this. Okay, now integral of this quantity, you can do it and we will get correspondingly this. Okay, 1 by root of 2 pi e to the power of minus y squared by 2. Okay, similarly, you can try to write fxx equal to 1 by root 2 pi e to the power of minus x squared by 2. Then is the 3.12 satisfied is the question. What is 3.12? Let us try to see. So 3.12 is the full integral corresponding to 1. Okay, whether that is satisfied. That is the cumulative distribution function in the whole of the region. That is the area under the curve, that whether that turns out to be 1. Okay, so if you just integrate that overall thing over there, right, whether it turns out to be, or you can just integrate this, within the limits x, within the limits minus infinity to infinity, or integrate this within the limits minus infinity to infinity. When you integrate this, it will be with respect to x. When you integrate this, it will be with respect to y. Okay, that is this. It will be with respect to y, and both he is tried to write, and that turns out to be 1. Okay, that turns out to be area under the total thing will be equal to 1. Now, are they independent? If you multiply this with this, you are not going to, if you multiply this with this, you are not going to get this. So therefore, they are not independent. They are not independent. So if there is any doubt, you can ask. We are still left with 1 minute.